Right, here are the answers to the test review that will help you prepare for the upcoming test. In this chart at the top, I am looking for the ability that you have to come up with an example that demonstrates the property and then the answer that is finished for it. The answers that I'm providing you are merely that. They are just examples. You may have different ones. As long as it is expressing the name of that property, then you're fine. So for number one, the product of powers property, it would look something like this. If I have x to the third power times x to the seventh power times x, I'm taking the things that have the same base and adding their exponents together. So the simplified answer would be x to the 11th power. Right? For the second one, power of a power, that would be where you have an actual power raised to another power, so something like this. And in my case, x to the fourth power raised to the seventh power becomes x to the 28th power. Right? For number three, the power of a product property deals with the distributing. So if you come up with a product such as 2x cubed y, and then you raise it to another power outside of the parentheses, that will demonstrate that you know how to distribute your powers. And when you're done with this type of example, you should have a finished answer. And in this case, it would be 4x to the sixth power y squared. For number four, it's quotient of powers, which means that it's a division problem of powers that have the same base. So if I do m to the 10th power over m to the 15th power, right? I have the same base of m and I need to subtract them. Or if you remember from what we did in class, wherever the large amount is, the leftovers will be down there. So if I take the 10 away from the 15, I still have 5 of them left on the bottom. And then because I stole all the ones from the top, there's a 1 up top. Right, so my final answer would look like that. For number five, power of a quotient would be where you have a quotient or a division problem, all raised to a power on the outside, something that looks like this. And when you do that, you have to give that power to all the things in the numerator and all the things in the denominator. Right, so for this one, 7 over 2 squared, it's going to end up being 49 over 4 as the final answer. For number six, the power of zero is anything that's raised to the power of zero. So in this case, if I use negative 12x all raised to the power of zero, then because it's all parentheses and that all of that in parentheses is raised to the power of zero, my answer is just 1. For negative exponents, remember it's about making them happy. So if you create a negative exponent, as long as you show me that you understand how to get the answer off of that one by turning it into an answer that has no negative exponents and everybody's happy where they are, then you've demonstrated that property. So this chart just gives you the names and examples of what they look like. You will have a matching section on your test that will require you to do the same thing. All right, for numbers 8 and 9, you need to fill in the blank. There are blank factors in the expression 4 squared times 4 to the 5th. If we simplify this, we end up with 4 to the 7th power. Remember, we talked about in class with the graphic organizer that another way to say this is 7 factors of 4. So there are 7 factors in that expression. The exponent tells you how many factors. For number 9, in the expression x to the 5th power, x is the base and 5 is the exponent. This is just knowing your components of what makes up a power. For 10 through 15, you are doing true or false type deals, so you're going to have to look at each one individually and determine if that is something you can do correctly or not. So for number 10, because they have the same base and it is a multiplication problem, we technically should be able to add them, and that's what they did. So 2 plus 3 is 5, so this is a true statement. For number 11, right, x cubed times y to the 5th does not make xy to the 8th. Because the bases are different, we cannot combine them together, so this is a false statement. For number 12, in division, if the bases are the same, we can subtract the exponents. Well, 6 minus 2 does not make 3, so this would be a false statement. For number 13, this would be your power of a power, where we multiply the exponents. 3 times 2 is 6, so this is a true statement. For number 14, any non-zero number raised to a power of 0 is equal to 0. That is false. If it is a non-zero number raised to the power of 0, it is equal to 1. For number 15, scientific notation, that is correctly written, true or false? Well, as long as the first number, remember, has a digit between 1 and 9 in front of the decimal, and everything else looks good, and it's a power of 10, this is a true statement. So you do have to be able to recognize true and false statements based on stuff that other people have done. Right, so looking at number 16, Teresa says that 2 to the 3rd times 3 to the 4th is 6 to the 7th. And then you have to explain the mistake and help her find the correct way to do this. Right? Well, there is no correct answer that I need you to worry about finding. At this point, you need to tell me that she can't do this. Right? So what you should have somewhere in your answer is that because the bases are different, the powers cannot be combined. If the bases were the same, then we could have moved on and done a lot more with this problem. But because they are different, I don't need to know what the real answer is supposed to be. Just know that it is not 6 to the 7th power. All right, for number 17, we need to figure out what John's mistake was and help him find the right way to do this. Well, if you look at it, it's got a power of 0 sitting right here with this 3. 3 to the 0 power is 1. So technically he should have negative 6 times 1 written in his work. He's got a 0, so he doesn't know his 0 property very well. If we do negative 6 times 1, then the official answer should be negative 6, not 0. All right, so knowing these properties are going to help you get to those right answers. Okay. All right, for the next several problems, the directions are going to be to use your properties and simplify. And notice it says to write your final answer as a power. You do not evaluate unless it's in the coefficient spot or unless it's in the fraction spot. All right, so looking at number 18, all of these have a base of 6, so we're going to combine them all together. We have 4 plus 6, plus remember there's an invisible 1 right there, so this becomes 6 to the 11th power. Okay. For number 19, this is showing your power of a power property. Because it's power of a power, we're going to multiply. This becomes 4 to the 15th power. For number 20, this would be your distributing. So you're going to give that power of 2 to the negative 2, the x squared, and the y cubed. Remember, because this negative 2 is negative, it needs to stay in parentheses when you go to square it. And then it becomes x to the 4th power and y to the 6th power. Also remember that your coefficient cannot be a power, so we need to turn it into a regular number. Negative 2 in parentheses squared becomes positive 4. And then x to the 4th, y to the 6th. All right, so if you continue on to the back, right, number 21 is your division property, your quotient property. All right, I've got the same base, so I'm going to keep the base of 2, and then I'm going to subtract the exponents. 4 minus 2 leaves me with 2 squared. Okay, because we are not evaluating and it said write your final answer as a power, you would leave it 2 squared. Right, for number 22, notice how the top one does not have parentheses and the bottom one does have parentheses, but they're essentially the same base of negative 3. So you're still going to subtract those exponents. What you need to understand, though, is that because they're both odd numbers, when you evaluate them, it's going to be a negative number over a negative number, which ideally makes a positive answer. So because these are negative 3 bases, I'm going to put negative 3 in parentheses, and I'm going to subtract 5 minus 3 and get squared. It did not ask me to evaluate it, so I'm going to leave it just like that. For number 23, it is a fraction, so I am giving my power to both the top and the bottom. And because it's a fraction, I can't leave exponents in this answer. The negative sign is right in the middle. You need to assign it to the top or the bottom. I always give mine to the top so I don't forget about it. All right, so I'm going to have negative 2 in parentheses squared over 3 squared. And I can't leave this because exponents cannot exist in a fraction. So we need to keep going. Negative 2 squared is positive 4, and 3 squared would be positive 9. So 4/9 is the final answer for that one. Right, for number 24, we can either make it happy first and then give everybody the power of 2, or we can give everybody the power of 2 and then make them happy. I distribute first most of the time. It's just my philosophy and the way I do things. You can do it reverse if you want. So I have 3 to the negative 2 over 5 to the negative 2, and because they're unhappy, now I'm going to flip them. So I have 5 squared over 3 squared. I can't leave exponents in my fraction, so I keep going, and I end up with 25 over 9. So whatever order you go in, the answer should result in the same one. All right, for number 25. All right, some of you may think it starts looking a little scary at this point. However, if you stop and slow down and think about what you've got and look at what you've got, it's really not as bad as it may seem. If you put the guys that are not written as fractions over ones, you're going to see that you have 3 fractions in this problem. So go ahead and go across the top and get all those together, and then go across the bottom and get all those together. So if I combine 2 to the negative 2 with 2 to the negative 3, I now have 2 to the negative 5 on the top. And then across the bottom, I have 2 to the negative 6. Now I can make them happy. So then I've got 2 to the 6th power over 2 to the 5th power. This is a division problem. I can't have the same base in the problem, so I keep going by subtracting my exponents, and I end up with 2 to the 1st power, or just 2. Okay, for number 26, all of these have a base of 3, so I'm just going to go and combine all the exponents together. I have negative 1 plus 3, which is 2, 2 minus 5, which is negative 3. Now I see that I have negative exponents, and you know you cannot have those in your final answers, so you keep going to make them happy. We put the 1 on the bottom, We flip it, so we have 3 to the third power with a 1 on top, and you keep going. 3 to the third power is 27, and the 1's on top. So your final answer is 1 over 27. For number 27, you need to do the power of a power first, and then you can start combining. So 2 to the negative 1 power is going to be 4 to the negative 2, and then times 4 to the 4th power. I have the base of 4, so keep the base of 4 and add your exponents. Negative 2 plus 4 is going to give you a squared. So 4 squared, right? And because it did say in the directions to simplify, you're going to leave it 4 squared. If it said evaluate, then we would go further. All right, for number 28, they have a base of negative 3 in parentheses, so we can keep the base and we can add the exponents. 2 plus negative 2 is going to give you 0. Remember, any non-zero number to the 0 power is 1. Right, for number 29, we're starting to put several properties together in the same problems now. Your coefficients, the 4 and the 3, need to be multiplied. So 4 times 3 is 12. Combine your x's. You have negative 3 plus 1, so that's x to the negative 2. And then combine your y's. 1 minus 5 is going to be y to the negative 4. And you see that you have some pieces that are not happy, so we need to move some things around. If you put a 1 under everybody, you can tell who's happy and who's not. The 12 is fine. Leave the 12 up top. It's happy where it is. The x and the y do not want to be up there. They want to go to the bottom, so it becomes x squared and y to the 4th on the bottom. So the only thing that still remains up top is the 12. If you go to number 30, right, there is no distributing. Okay. You simply need to take and start combining. The negative that's on the outside will join whatever happens when you do 5 times 2. So 5 times 2 is 10, and I'm going to slip the negative in front of it because it's a negative answer. That's what that negative outside right there is going to do to your problem. So now combine your x's together, which there's only one of them, so x to the negative 3, and then combine your y's, so you have 1 minus 3, which is y to the negative 2. Go at this point and make the ones happy who are unhappy. If I draw my line and put a 1 on the bottom, you can see that the x and the y are not happy. The negative 10 is happy because it's a positive exponent. It doesn't have a negative exponent attached to it. So when you write your final answer, negative 10 stays, but the x cubed and the y squared go to the bottom. All right, for number 31, still no distributing to do, so we're still combining them together. Again, take your coefficients and multiply them. Negative 2 times 4 is negative 8. Combine your x's. X squared plus x to the negative 2 is going to make x to the 0. We'll deal with that in a minute. Then you have y negative 7 with y 1, so that's going to be y to the negative 6. All right, we know that this x to the 0 right here is going to turn into a 1, so essentially it's just going to drop out of the problem. All right, so in your final answer, you're going to have negative 8 at the top because negative 8 was happy where it was, but the y is not happy up there, so it's going to go to the bottom. Your x completely disappeared because it turned into a 1, so there's no longer an x in the problem. Right, if you go down to number 32, again, there's no distributing. At this point, you want to simplify, combine, and make happy in whatever order you want to do them in. There's really no one way you have to do this. Right? In this type of problem, I usually multiply straight across and then clean it up at the end. You can do your own thing, but we should all end up at the same final answer. So if I go straight across, 2 times 4 is 8. X squared and x7 makes x to the 9. Y and y squared makes y cubed. On the bottom, I keep the 4. And I keep the x cubed, and then I combine my y's. Y to the negative 2nd power and y to the 1st power is going to be y to the negative 1. So at this point, I'm going to try and simplify and move things around at the same time. Right, so if I take the 8 and the 4, 8 divided by 4 is going to give you a 2. Right, so in my final answer, because the 8's up top and it's the bigger number, my 2 is going to stay up top. All right, when I go to my x's, I've got 9 x's sitting over top of 3 x's. This is where you subtract. I steal the 3 off the bottom and take the 3 away from that 9, and that leaves me with 6 of them still hanging out up top, or 9 minus 3 is 6. Right, and then if you go to the y's, you'll notice that the y on the bottom is not happy, so he's going to come up and join those 3 y's that are already at the top, and that's going to combine to make a total of 4 y's at the top. Right, and because there's nothing left on the bottom, you don't need to write the 1, just know that it's invisible and don't even put it there, but there's your final answer, 2x to the 6, y to the 4th. All right, when you go to 33, now you're going to see the distributing coming in between 33 and 34. All right, so again, I'm going to give the power to everybody first and then clean it up. You can clean it up and then give the power if that's what you feel inclined to do. All right, most of you, though, I think are going to stick with me on this part. All right, so if we give everybody the power of 2, we have 5 squared x to the 10th, y to the 2nd power. On the bottom, we have x to the 6th and y to the 4th. Right? We're going to turn 5 squared into a number because you can't have a power there. So 5 squared turns into 25. Then we look at our x's. You have 10 of them sitting over top of 6 of them. Right? 10 minus 6 is going to leave you with 4 left over, and they're going to go on top because that's where the bigger number is. So right now we have 25 x to the 4th power sitting up top. Right? But then if you look at your y's, you have 2 up top and 4 of them on the bottom. So there's more on the bottom, which means all of our leftover y's are going to be on the bottom. If I take the 2 away from the 4, I still have 2 left on the bottom. So there's the final answer, depending on which way you try to do this. For number 34, again, we're going to take and give the power of -2 to everybody, or in this case, I'm going to try simplifying first and then doing the -2. So if you do this in a different order, again, just check your final answer, right, and see if you can follow along what I'm doing, because it is just another way of getting the answer. Right, if I look at what's in the parentheses, I know 3 and 15 can reduce to 1 and 5. That's just reducing. And then if I look at my x's, I see x5 over x3. Well, I know the 3 on the bottom go away, and the 5 up top become x squared. And then if I look at my y's, I know the y on top goes away, and the y5 on the bottom becomes a 4. I have already simplified that fraction. Now I can give the power of -2 to everybody inside. You might want to rewrite it, though, just so it's a little cleaner to see. So right now I'm looking at x squared over 5y to the 4th, all being given a power of -2. And then you can keep going. So now I'm going to distribute to everybody. This gives me x to the -4 over 5 to the -2 power and y to the -8 power. And then I'm going to make things happy by flipping them around. When 5 squared comes up to the top and becomes happy, it becomes 25. The y to the 8th is going to come up to the top and be happy with y to the 8th. And the x to the 4th is going to go to the bottom and become happy. So your final answer is 25 y to the 8th over x to the 4th. Right? And again, you might have done this in a different way, but we still should have ended up at the same answer. All right, for the rest of the problems on the review sheet, it's going to go back to scientific notation, right, which is the most recent thing that we've done. All right, and the first few are just being able to convert, and then the last ones are being able to calculate. All right, so for number 35, if I take 1.77 times 10 to the 8th and I make it into a regular number, remember the 8 tells you to move the decimal 8 places, and because it's a positive exponent, you're going to go to the right. So after you move your decimal 8 times, you should end up with 177 million. Please make sure your commas are in the right spots and that you have the right amount of zeros. For number 36, right, 3 times 10 to the -6. Remember, if it's a negative exponent, you take the decimal and you go to the left. If you don't see a decimal, remember it's right behind the decimal or the number that's already there. And when you go to the left, you're making a smaller number. So for this one, it would be 0.000003. Very tiny number. All right, for 37 and 38, you're going to take the number given and turn it into scientific notation. So for number 37, we have 27 million, right? The decimal is in the back behind the very last 0. You've got to move it to where you have the first number with a digit between 1 and 9. So this will be 2.7. And to get that to be 2.7, you had to move it 7 times, right? It's a positive exponent because your zeros were in the back. Remember, if your zeros are in the back of a number, it's positive. If the zeros are in the front of a number, it's a negative exponent. All right, so for number 38, 0.004, all right, I want to get it to where there's a number that's not a 0 in front of the decimal, so that would have to be 4. You can write 4.0, it's the same thing, times, and then how many times I had to move it. Again, my zeros are in the front, that's a negative exponent, and I had to move it 3 times to get it behind the 4. And so there's your answers for those two. Right, for 39 and 40, this is the multiplication and division part. You can use your calculator to check behind yourself or to assist you. However, remember that it is faster for us to do it mentally and with paper than it is to type it all in the calculator, because we happen to be faster than the calculator is at this point. All right, for number 39, remember take 1.4 and 5.6 and divide them. That will give you 0.25 times 10, and then remember to deal with your exponents. Right? If you subtract 10 to the 3rd over 10 to the 8th, because it is a division problem, you get 10 to the -5th power. Right? And that looks like it's almost right. However, if you remember, you can't have a 0 in front of the decimal. So we've got to move that decimal one more time. Okay? And when we move that decimal one more time to the right, you're actually taking away a power from it. Right? So instead of having 10 to the -5, you're going to have 10 to the -5 minus another power. So this is really 2.5 times 10 to the -6. Right? Now again, if you're not sure about that, take and do it through your calculator and convert it to standard and then convert it back. Right? But some way you've got to get to the final answer being in scientific notation. All right, for number 40, this is a multiplication problem. So multiply 3.8 times 1.4. And if you do that, you get 5.32. And then remember, in the multiplication properties, we add our exponents. So -2 plus -3 is going to give me -5. And if I look at my first number, 5.32 is okay. So this problem is done. There's absolutely no more to do to this. All right, so these should have been the topics that you should have been preparing for the test. Hopefully you will do a good job on the test and that it will come out in your favor.